Hi, I'm Kent. I've been thinking about how to extend my mold system to do two-part molds. In the last video we went ahead and explored stacking two different forms. In this one I want to see if we can go ahead and make a real two-piece mold system. So as a quick recap, we made this form last time, and this is made by slip casting two different forms, the bottom and the top, and then joining them together. And the key insight is that for at least some two-part molds, the ones that are split horizontally, it basically is the same process. The bottom mold is the same as the one-piece molds we've been making, and the top mold, if we turn it over, is almost the same. The key difference is it has a hole in it. So we want to be able to start making forms like this. So here's a real two-part mold system. It has the cavity in the bottom with a nice taper to it, and the cavity in the top, if we flip it over, has the same taper. And again, there's a hole for the slip. And then this joins together and we can slip cast it. So when we made this form, we weren't actually making a two-piece mold system. We took two one-piece molds and joined the resulting form together. However, it shows us what we need to do. In particular, we use these two molds here, and to be able to put them on top of each other, one, the diameter needs to be exactly the same, and this is the same part, so that is the case. However, if we flip it over and try to stack it, the slip well gets in the way. So that's one of the things we need to address in this video, is how do we get rid of the slip well that I tried so hard to add in for my one-piece molds. And then once they're stacked, we need a hole to go and put in here so we can pour the slip in. Again, like we have in a real two-piece mold. Shapecast doesn't support two-piece molds right now, it only supports one-piece molds. However, these changes are relatively straightforward, and I think we can hack Shapecast and the resulting STLs to go ahead and give us a two-part mold. So let's go ahead and do that. All right, so here is the design I want to make. Basically, I want to make a sphere that has the top open, and then I've added a little bit of foot. I drew this by actually creating a sphere and then starting to cut it up. And so based upon what we learned last time, if we can cut this in the middle, we would then basically would have two one-piece molds that we would want to try and join together. And so that's exactly what I did. There's actually two lines here. So one is the bottom part, and then the other is the top part. So let's start with the simplest one, which is the bottom part here. So here's the bottom. Basically, I just removed the top. This is one line just like I needed. I went ahead and uploaded this to Shapecast and got the resulting STL files back. And here is the inner mold. So this here is the foot for the bottom, and it goes around, and it also has the slip well. Well, the slip well is the problem. Somehow we need to get rid of this. In general, STLs aren't very easy to edit. However, you can do some modifications to them. In particular, one of the things that's often supported is a cut. So here on Prusa Slicer, what I want to do is basically cut off the slip well so we only have the bottom part. So we can do that by doing some measurements. So I want to measure from this face here to the bottom, and that's 14.996 millimeters. So I'll copy. Then I want to do a cut at that height. And I want to keep the top object and not the bottom one. I can perform the cut, and there we go. We just got rid of the slip well. So all that work I went to go ahead and put it in, it's now gone. The challenge is we lost all the features on the bottom, so we're gonna have to treat this like some of our original molds. However, it did give us the right shape. So this is an inner mold that's completely functional. So by doing that cut in the STL, we basically removed this piece right here. So now we'll have a flat piece right here that we can use for our mold. So that's the bottom. That's relatively straightforward. Well, what about the top? So here's the top form. I just went ahead and flipped it over. The problem is if we gave this to Shapecast, it's going to go ahead and move it over. It's going to treat this as the origin line about which to rotate it, and we don't want that. So we actually need to draw a line over to the center without moving this so it doesn't get shifted. That way the diameter of the mating faces will be correct. However, I want to do something slightly more complicated. So I just drew in this geometry here. So one extends all the way to the midline, so we won't have a problem with it shifting. However, this will act as a slip well. So this here will wind up being a hole inside of the plaster that we can use to pour the slip in. Hopefully that'll make more sense in a minute. In general, I don't want you drawing the slip well. It's done automatically for you, but again, we're kind of abusing Shapecast to go ahead and do this two-part mold. And here we go. Here is the top part. And again, we need to slice off the slip well, so we're gonna do the same trick at the measuring. And there we go. This is the top part of the mold. So now we can go ahead and print those out. And here are the two forms. The these will come together something like this and create some sort of moon jar basically. This here will be the area that's going to be for our slip well, and this down here is the foot. If you want to do this yourself, you'll then have to go and use cowle boards or a bucket, build up a structure around this. Since the outer mold, we cut off the features that it needs. One thing you want to be very careful of is that the bottom's very flat. We're going to go and take the resulting plaster and put it together, and those surfaces will need to mate very flushly. I, however, am not going to do that. I have access to the source code, and I managed to go ahead and change the slip well to be size 0, which has the similar effect of removing it. However, I got to keep my internal geometry so I can use my outer molds as well. So I did that on both pieces. Again, you guys won't be able to do that, but by doing the slicing I just showed you in the STL, you'll be able to get something similar. You just have to do something else for the outside mold. I printed these out on a relatively high print setting. However, there definitely are some 3D printing artifacts and some layer lines. So I'm going to use the trick I showed a few videos ago and use this filler primer to go ahead and put down some heavy coats to fill in any of the valleys between the print lines, and then sand it off to make it nice and smooth. That will take a little bit of time, so let me go ahead and do that, and we'll jump back when we're ready to make the mold. It's several days and lots of priming and sanding later. So I went ahead and built up several coats of the primer and then sanded it down. I did that on both halves. I can still see a little bit of banding here. I don't really feel it too much though. So I suspect that maybe is just an artifact of the color. I don't see any of the layer lines, and that's true both halves. In my previous video talking about using this primer, there were several suggestions on using other materials. I don't think the material you use to build up the surface matters too much, so much as the sanding itself. So the primer definitely builds up and will fill in all the different valleys, but it also is filling up all the humps. The sanding, what it does is it takes down all those humps, so they wind up being smooth. You could potentially use something like resin as well. That might smooth out some of the valleys a little bit, but you still want to be able to take off the surface. So unfortunately, the sanding is really the key part. If you're following along at home and just hacking Shapecast to do this using the trick with the slicer, you'll need to build up cowle boards, as I mentioned, or put this in a bucket. Since I was able to modify the software slightly, I went ahead and started putting together my mold system. I have the outer pieces as well. So I'm going to go ahead and finish assembling the molds, and then we'll mix up plaster. One of the things I've noticed that's a little bit tricky is getting the inner mold to align with the ring. It's covered up, so it's really hard to see. The outer one you can see from the outside. So what I did is I just took a Sharpie and marked where a couple of the holes are that are underneath the gasket here. So now if I get those aligned and it's centered, it should hopefully go together. All right, got those two started. That's usually the hardest part. Now I can go around and put in the rest of the screws. Also notice I'm alternating back and forth. That's in case I have any slight misalignment. Since I glued this outer ring together, it might not be exactly a circle. All right, there is the inner mold all secured down, so it's nice and attached. All right, let's go do the top half of the mold. Also notice that I went ahead and marked all these pieces with a T. These top and bottom pieces look very similar. They may actually be identical, but I didn't want to risk that, so I just took a Sharpie and marked them as they were coming off the printer. All right, and here's the top inner mold, all done. All right, next is the outer molds. I went ahead and pre-assembled this. I left it a little bit loose so to help with alignment. And again, I want to offset the joints here, so I'm going to rotate this by 45 degrees. And here I can see the top and the bottom, so the alignment's a lot easier. All right, and there is the mold complete for the bottom half. Go ahead and do exactly the same for the top. All right, and there is the top half. So in real time, that took maybe 25 minutes, including all the filming bits. One thing to note about the top half of the mold is that this slip well that we drew in manually protrudes all the way to the top. We want a hole here, so the plaster only needs to come to this part. Actually, it should probably come just slightly below that. This required another modification, but to my outer mold system, so that wouldn't apply to you right now. So I think with that, all of our mold prep is done. Let's go ahead and reset for plaster. Using Shapecast, I went ahead and spit out the interior volumes for me and did the calculations for dry plaster and water. I should have a little bit more because the original mold over here was a little bit taller and I sliced it off manually, but better to have too much than too little. I'll take the dry plaster, put it onto the water, let it slake for 3.5 minutes, and then I will mix it for 4, and we have enough plaster for both, so I'll go ahead and pour it into both molds. All right, the bottom one first, since it's a little bit easier. And the top. Let's see if I can get it. Give these a good shake. A little more plaster in this one. All right, and then wipe off the protrusion here, so we don't want the chip plaster off it. All right, we'll go ahead and let those set, and I will clean up my mess, and we'll come back to it. The plaster is set and is cooling down, so let's go ahead and demold these. All right, there's the ring for the first one, and the ring to the top. Looks like we got plaster all the way down the bottom. That's good. All right, let's remove the outside. Comes off just like that. Perfect. While it's soft, skip this part right here. And there's usually just a little bit of flash between the pieces. Just rub that down. So there's the outer mold. The inner mold's probably stuck. So we'll get that in a second. Let's go ahead and do this one. Also looking really good. I've caught a couple of bubbles on the outside here. Our two mating faces are looking pretty good. So let's go ahead and work on removing the inner mold. I've got my isopropyl alcohol and water mixture. It's been in my freezer. Dump this in. Okay, so we're getting the PLA cold, so it shrinks just a little bit. And that's it. This one's probably ready too. No, not quite. This is the harder one since it has the piece all the way through the bottom. And I might not have put enough of a draft angle on it. Nope, that's enough. All right, there are our two mold pieces. Dry those off and they should be good to go again if we want them to. Here are our molds. They're looking pretty good. I see a couple of small little bubbles, but I think overall we are in good shape. So the way this will work is this will be the bottom, this will be the top, and we'll pour slip in here. Also noticing a little bit of rocking, so they're not perfectly flat. Maybe there's a few spots here. I'll try and whittle down a little bit. Let's get here where the seam between the ring pieces was a little bit smoother. Brush these off. Oh yeah, that's much better. All right, cool. There is our Death Star mold. One thing you'll notice is that there are no alignment features. These are pretty flat against each other, so hopefully they'll mate well. This is rotationally symmetric, so it doesn't matter which way I put it on this way. All it needs to be is in the center. Since these two are exactly the same diameter, if I center this piece here over the top, that should mean the inside is also centered. However, since we are just hacking shape cast right now, there's no features in this. The plaster is dry. Let's go ahead and slip cast a pot. So I had these sitting in front of the fan and they actually dried out really fast. So to assemble the mold, we need to stack them on top of each other. And again, we want these kind of radially aligned, so I'm just going to feel that. And I'm going to go ahead and rubber band this together just to make sure it doesn't separate. Okay, double check the alignment, make sure we're good. Now slip goes in here. So I got it all mixed up, so I should just be able to pour it in. Inside the hole's a good idea. Oops, a little too far, all the way to the top. My slip well in this is relatively small, it's just that little circle right there. So I spilled some on the outside, but I don't see any leaks, and the level's already going down. Let's go ahead and keep an eye on this and see if I need to top it up. Now it's actually fascinating to see it absorb so fast. I have seen people that will put a cone in the top here basically to create some extra space, so I might need to do that. Maybe I'll 3D print something to put down in there. And top it up more carefully this time. All right, this will sit for about half an hour. It's usually what I let my mold sit for. I'm going to keep an eye on this one though, just to make sure that my slip level doesn't fall too far. We'll be back in just a sec to then drain this out. I topped up the slip level several more times. It's kind of fascinating, gives me some ideas. In the meantime, let's go ahead and dump the slip out. Be careful not to shift this around. Oh, and it is heavy. All right, I'll leave this upside down for a while to let the rest of the slip drain out. And then we'll come back and demold it and see how we did. This has all drained now, so we should be ready to demold it. I'd already scraped the slip I spilled on the top off once, so let's do the rest. Remove the rubber bands. And I suspect the bottom's going to come off easier, so I'll flip this over. Perfect. Got a little bit of flash right here, but not much. Grab a wear board. Let's see if it will come out. Not yet. So the other thing I'm going to do is go ahead and trim up the slip well a little bit. Okay, so I just removed it. Oh yeah, I was holding on. And there we have it. So indeed the bottom came out really easy. And the problem was this part here, this ring, the clay was holding onto. So I just went ahead and trimmed around there. So we still have the sloped part back here. And once that's done, it just came out real easy. So I'll let this firm up a little bit and we'll take a better look at it. We've got a bit of a parting line here. But it looks really good. And then this part here where the slip well is, we'll go ahead and cut that. But again, I want to let it firm up a little bit. Overall, this is really cool. I have not made anything remotely like this before. All right, I'm gonna let this dry a little bit more before we play around with it. I couldn't help myself, I went and did another one. So I went ahead and slip cast this one as well. This one I had a bit of a problem with it leaking out the side, so it didn't mate as well this time around. So let's see if I can get it out easier now that I've done one. So first thing I want to do is trim this piece right here. And I want to try and not get this down inside the pot if I can. Flip it over, which means you won't be able to see it. Okay, yeah, upside down, that worked pretty well. I've never slip cast pots like this. If you guys have tips and tricks on how to go ahead and trim these to demold them, definitely let me know. So now we'll pop off the rubber bands. See which side wants to come first. Top came. Yep, there's the flash we got. Perfect. Set that down right there. All right, yep, we definitely didn't get a mating face as well this time. Trim this up real quick. Keep this nice and clean. All right, I'll stack this back together and let it dry, just in case it decides to move at all a bit on top of itself. So this one here should be dry enough to handle, and it looks pretty good. All right, so let's go ahead and trim this one. It's been sitting about an hour, basically the time it took to slip cast the other one. I'm just gonna use this sharp blade and cut down. So this here was the part that we added for the slip well, so I just want the sphere. So I'm gonna basically cut at this seam right here. And go nice and slow, because I am not patient with these types of things. And this is another area, if you guys make pots like this, how do you like to trim off this part of the slip well? Here we go. That is not perfectly clean, but not bad for a very first attempt. Not too sure if I want it sloped in or straight down. All right, that'll need a little bit more attention. So now I can pick it up and show it to you. Got a little bit of a nub in here. I think this is where that bubble is. And let's see what we can do about the seam. So not too surprisingly, there is definitely a very slight layer shift between the top and the bottom. I'm talking like fraction of a millimeter, I think. I probably could have put another couple coats of primer on. I am seeing a few of the artifacts from the 3D print coming through. I don't know if you can see those on camera, and I suspect once this is fired and glazed, those will all but disappear. However, this is really, really cool. I kind of drew a sphere because it was a form I haven't played with before, and I'm glad I did. So one of the other things I did is I made the opening at the top intentionally small. So the smallest I can make it is basically where the slip well is. I guess I could leave the slip well on, but that wasn't the intent. But I can also cut the opening larger, so I can make it, this big in diameter if I want, just by cutting lower. The other thing I could do is actually I could cut it at an angle here, so I could cut a hole over on this side and have more of an opening. In general, I don't like modifying my pots too much, but I think that would be a relatively straightforward thing to do. Maybe I'll make a template or something to make that cut a little bit easier. So there we have it, a real two-part mold. I'm definitely gonna make some more pots and see how I like this system. I suspect there are a few things I'm gonna wanna change, but I want to get a little bit more experience first. I may actually go ahead and make a second copy of this just because the form's so fun. So in terms of the changes, one is getting these surfaces to mate really well, nice and flat. The 3D print that I used this time was okay, but with the segmented rings, it's not perfectly level. So these pieces here, just super gluing them together, they wind up being warped a little bit, or potentially screwing them down might warp it a little bit. So this is a consideration and something to think more about. I can't make this in one piece because it winds up being too big for my printer bed. Another thing to add would be some keys for alignment that would potentially help with the centering. I don't know if it'd be good enough to help with the small layer shift I have in this pot, but it is something to explore. So that will require modifying this bottom ring. The simplest thing to do would be to add a small protrusion here, which would wind up with a divot in the plaster, but then the corresponding feature would need to be a hole. So that would make this ring fatter. And then I actually have to figure out how to add in the geometry, kind of like the bolt holes. I would need it to go around the outside edge here in the middle of the ring. I think that's doable. However, I'm not sure that's exactly what I want to do. The other issue is these mating surfaces. If I really wanted them to line up well, I could pour the plaster into the 3D print, let it cure, and then instead of having the ring on the other side of this, I'd actually pour the plaster against the existing piece. So basically mold soap this face and then pour the plaster against it. I have no idea how to get the forms to do that just yet. I have some ideas, but I don't like any of them. I'll have to think about it a little bit more. So if I want a perfect seam, or basically a seam as good as I could get, that would be the way to do it. So basically pour the plaster in place against itself. If you watch Fantiki, and if you don't, you should, he does this with his hand carved molds, and it winds up with a really nice plaster seam. If I don't do that, then I'm basically relying upon the alignment of the 3D printed pieces to give me a nice mating face. And it's not bad, at least in these two prints, it worked pretty well. So that's what I want to do with playing with it a little bit more, see how much this is really an issue. The other thing that occurred to me is I could actually have something on the outside that clamped this together, like another 3D printed piece that could potentially help with the alignment. Is that better than modifying the plaster? I'm not so sure. It's just a different strategy, so I'll think about that as well. And the last thing, which was a little bit of a tangent, was watching the level of the slip drop. I know this happens, it's just the way the slip casting works. It gets sucked into the plaster, and when the plaster was dry, there was lots of space for the water to go into. However, it got me thinking in terms of watching the level of the slip drop. That might be an indicator for how thick the walls end up being. If you know anyone that has done that or has a model for how that works, I would love to know. Usually I just go by time, and it seems like most people go by dwell time to figure out how thick the walls are. But let me know if that's interesting. Is getting the thickness of your pot dialed in a tricky spot for you, or is time good enough? I think it's interesting to figure out, but if it's a real problem, I might prioritize it a little bit more. And as I mentioned, I think I will go ahead and do some sort of funnel so that I don't have to keep refilling it. I don't like babysitting my molds. That may just be something simple and 3D printed, and it may be an add-on. If I go ahead and incorporate the two-piece mold design into Shapecast, I could potentially go ahead and model that up and have it printed out as another piece. Or I could change the geometry of the slip well just to hold more slip. So there we have it, a real two-piece mold system. I'm definitely going to play around with this form a little bit more, and I think I'm going to go ahead and make up a few more, probably using the same technique. That will give you a little bit more experience and figure out how I might want to change things going forward. If you have any questions or comments, do let me know. Thanks.